Use the vertex hk and a point on the graph xy to find the standard form of the equation of this quadratic function. So hk equals -1, 0, and xy equals -2, 3. So hk, that's the values of our vertex. And the vertex form, or the standard form as they're calling it, of a quadratic looks like this. F of x equals a times x minus h quantity squared plus k, where the vertex is literally located at -1, 0. So if I have the location of the vertex, I can actually take the coordinates of those and plug directly into my formula over here, and that will get me started pretty far into this problem. So I would have f of x equals a times x minus, and then I'm plugging in the value of the x-coordinate, so -1, well, the x-coordinate of the vertex, that is, then squared, plus the y-coordinate of the vertex, which is 0. So simplifying, that gives me f of x equals a times the quantity x plus 1 squared. Now, the next thing that I have here is that some point that exists on my parabola is at -2, 3. That's an x and a y value. And you can always substitute a y value in for f of x. So I could take the coordinates of this point and say 3, which is the y value of that, equals a times the x value of this point is -2 plus 1 quantity squared. And the only variable left now is the a, and I can solve for a. So 3 equals a times -2 plus 1 is going to be -1, but when I square it, it'll become a +1. So I learned that a is equal to 3. So my final answer here is f of x equals 3 times the quantity x plus 1 quantity squared. This would have the vertex at -1, 0, but then pass through the point -2, 3. And you could show this by graphing, but this certainly will happen.